the limit of a function, and it's what f of x is approaching as x approaches a single number. And so we're looking from the left and from the right. But we can also talk about the limits from the left and the right kind of separately. And so there's notation for if we're wanting to do that. And I did post these notes on Canvas as well. So if you wanted to print that off and follow along, or if you wanted to just write on it using Kami or something like that, you can do that too. But I have a graph, and so let's look at the notation. If we're coming from the left, we're going to put this little negative sign kind of where the exponent would be. So it's saying I'm approaching A from the left. And over here, x is approaching A from the right. So on my graph, let's start with this column. The limit of f of x as x approaches 2 from the left. So coming from the left side. So we're using a graph today. So as I'm coming in from the left side, what y value am I getting closer and closer to? So here, coming in from the left. If I plugged in 2.99999, what am I getting really, really close to? I mean, 1.9999. I'm going to get like 2.99999 for the y value, which means I am approaching 3 from the left. As x approaches 2 from the right, so that means I'm coming in from this direction. And that y value is 1. So what is the limit as x approaches 2? Well, the left side is approaching 3. The right side is approaching 1. So the limit does not exist. Now, I also just threw in, what's f of 2? Well, at 2, both of these have open circles. So this is undefined. There is not a point defined for 2. Now let's look at 4. So if I'm coming at x, as x approaches 4 from the left, so I'm coming this way, getting closer and closer to the x value of 4. My y value is approaching 2. If I'm coming in from the right, the graph is approaching 2. So what would we say the limit is? Left side approaches 2, right side approaches 2. The limit approaches 2. So f of x is approaching 2, but where is f of 4? Aha! When x is 4, the actual point has a y value of 1. So I wanted to show this because you can have a limit to one point, but an actual point exists somewhere else. Now let's do 0. 0, so when x is 0 is here. Coming in from the left side, it goes to 2. Coming in from the right side, it goes to 2. So my limit is 2. And f of 0 is 2. So there are cases where your limit from the left, the limit from the right, they're both approaching the same point. And so we have a limit overall, and that point actually does exist. And so we have a point right there. So I'm going to go back to one we had done last time, and that was the limit of x over absolute value of x. But I'm going to say as x approaches 0 from the left. So I'm going to pull back up my table from last time. And if we were coming in from the left side, what was it approaching? It was approaching -1. If I'm coming at 0 from the right side, it's approaching 1. So that's how we can use this notation of left side and right side limits.